So it seems like for now we will not be getting Copilot. 'Tis the tragedy. Okay, so program we need. Let's see. So this is going to be okay. Let's make a new file and let's name it path.md. So B. Nope. B. Mm, CLI utility for browsing different image boards, including utilizing image backends mo- on modern Linux terminal emulators. So, plan support and completion state. Oh, no. Please stop opening anew. Okay. So, the program we're going to be making today, or for the next few days, I'd suppose, considering I'm about to be on Thanksgiving break after Monday and Tuesday, is a command line utility for browsing different image boards. And the main feature differentiating it from others is that it will be utilizing image backends on modern Linux terminal emulators. So, like over here, if I. Nope. So, like here, if you can, yes, you can see that. So here on Kitty, which is a terminal emulator for Linux, it's the one I use most usually. See, I can tell it to use the Kitty image backend and give it an image, and it prints that image to the screen. Now, what I'm looking to do here is I'm looking to implement a image board browser that has the ability to show you the image in the terminal as opposed to something that's just a client that would open up the image in, or like the image in a different place. Now, I'm not sure how I'm exactly going to do this in .NET or C Sharp, but I'm not too keen on not doing it in C Sharp. And that's just me personally, I guess. So, um, that's the program we're going to be working on for the next few days. So, what we're going to do is we're going to make a class interface main. So for this, we're going to be using the terminal.gui library. And this is going to make it a lot easier to actually have the GUI open in the terminal. So using terminal.gui. So terminal t equals new terminal. I do believe, okay, now terminal.gui dot application app. Okay, so main, so interface main, public interface main, string args. So this is going to be the main thing of our place here. So args. B dot interface main args. Yes, that's what I want. I'm going to do new, and that is going to be our program.cs. So what's instantly going to happen is it's going to pass off the program over to interface main. So over here in interface main, we need to do application.init. So now our application is initialized according to terminal.gui. So now that our, okay, I'm not gonna lie here. I've never once used this library, so I'm gonna be pulling from documentation a good bit here. Terminal.gui is a cross-platform terminal GUI toolkit for .NET, and this is some of the things that it has. And now you can very much understand. Actually, no. I don't think we're going to be using it because it doesn't have a way to natively or non-natively post images to the terminal screen on things that support it. Okay, so that's the image rendering terminal library that I remember having to use in something else. Ubersug. Okay, we can use this in all Linux. Okay, so what we need to be doing is we need to be utilizing Uberzug. But the thing is that it's a Python library. So we're going to be needing to make internal Python calls, I believe. So I think okay, so Uberzug. If I am pronouncing that wrong, please do tell. I have chat open over here. Okay, so no. Maybe okay. So we're looking at the source code for iCat, which convert terminal graphics protocol. Okay. Getting the window size. Okay. Okay, so we're gonna need to struct win size sc ioctl. Some terminals return 0 for the width and height values. Such terminals should be modified to return the correct values. Examples kitty and xterm. So a minimal example to display PNG images in kitty using the most basic feature. There's a graphics protocol, serialized command, command payload, write chunked, then write to the std out buffer, and then flush it, and then clear the command. So what exactly is the command here? Okay, so what we're looking at here. What we're looking at here, we're seeing over here. Okay, serialized gr command, which is used right here. Payload equals chunk m equals m. So payload equals cmd.pop payload or none. So this is that payload value over here. So this is the chunk. Then cmd equals that. Okay, so we're turning this command into a string by joining the key equal value, comma, for each item. Then we're appending, then we're redoing, we're assigning W to ANS.append for some reason, which that just moves the function reference, well, more so copies the function reference. It doesn't really do anything except make code shorter and harder to read. So we're appending, we're doing W with this byte sequence, and then we're doing the ASCII encoding, and then if payload exists, we're putting the byte of semicolon car, then we're putting our payload, then we write this byte, then we return a byte assuming null determined string joined. Basically, we're returning the string representation of the ANS array here, which we've already exposed is mainly just byte strings. Well, it's only byte strings, let's be real here, because that's what this encode function is returning from this string, which we assign up here. So we're writing the serialized command of this chunk. Okay. So with sys open argv -1 rb as f, write chunked data a equals t. So what does a do here? Okay, so we're also getting a equals t into this command up here, because this is getting passed into CMD, which is getting passed into CMD. So that, which is getting passed in the CMD, which is getting put into the CMD string, which is getting put into the payload and returned. So what we're doing then is we are using the right chunked function with a equals t, f equals 100, and data equals f dot read, which returns, since we're opening this in byte form, which is how Python works, we're returning basically a byte sequence or a byte array, if I remember correctly, usually considered a buffer that contains the full and undivided image data. So that's what data is getting sent. So we're getting standard B64 encode, which is from the base64 library. So we're assigning data to the base64 representation of itself. Then while data. So while data is not null, we get chunk and data. We reassign data to data 4 kilobytes ahead, and we get a 4 kilobyte buffer or chunk. And then im equals 1 if data else 0. So I believe that im here is some sort of whether or not this is the end, because if data, meaning if data is still a string with length longer than 0, im will equal 1, and im gets passed to this serialized gr command, which gets put into the command, which eventually gets returned and pushed to the standard out buffer and flushed. So I believe that it's some sort of thing that signifies whether or not this is the end, the final chunk. So then it calls the serialized gr command that we were talking about earlier, and it writes it to the system standard out buffer, and then it flushes the buffer and clears the command, which I believe, yeah, we do. We are, okay, so that makes sense because we already have, I believe. I don't know why cmd.clear is there. Oh,